Okay. Okay, so good morning, everyone. My name is Pathanamon. So today I'm going to talk about an online unit proposal for my subject, software design and modeling. So, so first of all, let me give you a little bit background about my subject. So this subject aims to teach the student about various techniques to create a tangible but still abstract representation for a software system before the actual implementations. So the main goal is to ensure that everyone have the same understanding and everyone can build the efficient software. So this is the kind of metaphor that I use my students. So if there is no a model, then everyone will have a different understanding. But when we have a model, then which is a representation of the software system, everyone will have the same understanding. So the student will learn how to make this thing from this subject. And in case you might wondering how it look like for the software, so I put some example in here. This is the modeling that they have to produce, should be able to produce after learn this subject. So for the target learners for this subject is the undergrad students, the final year in the computing and software system. And this subject is also offered for the master student for the first year in software engineering. And the student should have a background about programming and algorithms. And about demographic, in this semester, there are about 180 students, and it is a remote learning that the student can be in Australia, China, Middle East, so all around the world. So it's completely online, as you will be aware of. So the intended learning outcome of this subject is after this subject, the student should be able to apply the learned technique of modeling and design to create a solution, should be able to evaluate and apply the appropriate choice of techniques when create a solution, and they should be able to work as an individual and as a team with effective communications. So based on these intended learning outcomes, these subjects have two main goals. The first one is the goal is to conceptualizing the construction process and techniques. So the students should familiarize with the construction process of a software model. And then the goal of this subject is to provide the opportunity to students to practice how to create the software models and how to choose the appropriate design for the real world problems. And for the second goal is to promote the teamwork and communication, because the software system is very large and it's very common that the developers have to work together as a team. So the students should learn how to work together and how to communicate. And as you see from my example, good software models mean effective communication because they have the same understanding. So basically, a software model is more like a communication tool. And then the student should learn how to use these tools for the communication and to ensure that everyone will have understanding and can produce a software system. So based on these two goals of this subject, which is a construction and communication, the designs of these subjects will be based on the constructionism. And more specifically, this subject will focus on learning by doing and focus on the collaboration, meaning that they have to create the artifacts together, and learning from peers, and the instructor are a facilitator, so it's not the main person to give instructions. So based on the constructionisms and the goal of this subject, the teaching and learning activity is designed will follow the blended learning approach, which is the approach to combine the online materials and provide and still keep the opportunity for interaction of the face-to-face classroom method. So basically, I will implement a synchronous learning strategy while allowing the student to learn at their own pace through the online techniques that for the asynchronous learning strategy. So basically, I will use both of them, synchronous and asynchronous. So how can I do that? So there will be three main teaching and learning activities in this subject. The first one is the interactive live lecture, which is a synchronous teaching and learning activity. So that this one aims to provide a fundamental concept about the software modeling and software design. And it is a live lecture. The student will attend my presentation, and there will be the interactive activities to increase the student engagement during the class using the Poll Everywhere or Kahoot. And after the lecture, there will be the online learning, which is asynchronous activities. So the supplementary online learnings materials, for example, like a short video presentation, some more examples will be provided as an additional support for students to learn, and then students can learn these materials at their own time, at their own pace. And the students have to learn and prepare everything by themselves for the workshop, which is the next activity to do the group-based exercise. So the last activity is the workshop, or which is they will do a group-based exercise, and it will be a synchronous activities. So the student will work as a team to try to solve some problems using the learn techniques from a given week, and then they will work as a team together, collaboratively, trying to create solutions. And there will be a tutor as a facilitator to support the students, guide them, and provide give a support to the student. And during this workshop, there will be a mark of active participation to encourage the participation and active learning for the student. So based on these three activities, it's follow the blended learning approach, which is emphasize the collaborative and active learning. Instructors is more like a facilitator, then students will learn from their peers. And there will be like a schedule that the students have to follow the lectures, and then there will be a independent and group-based activity to ensure that they consume and they understand the content and can be applied what they learned on the problems. And this then blended learning is very suitable for the online learning because it's synchronous and asynchronous, and it's online. All materials are online, so they can be anywhere in the world to attend this subject. So that so based on this, they give a lot of flexibility. So the lecture and online learning is the individual learnings, and the attendance is not compulsory, but the workshop or the group-based is compulsory, and it's happen every week. So it means that the students have to follow follow the curriculum to be able to attend the workshop and get the marks. And based on this, it gives lots of benefits. So the first one is it allows the student to learn at their own pace for the online learning. For the slower learning, student can repeat and review the materials as many times as they need. And for the faster, student can move ahead at a quicker pace. And it's also help the student to maintain the engagement. The workshop activities will ensure that the student will follow the curriculum. They understand the materials in each week and can do the work in each week workshop. And the live lecture also increase the interaction between student and the instructors, because they can ask the question. Yes, almost done. And then the last one is the benefit is promote collaborations, which is that they have to work together as a team, so they can learn from the peer and they can practice the communications. So for the tools, I use Canvas as a main hub to collect all the materials. All the tools is support the collaborative activities like Draw.io or Google Docs. And I use a lot of communication tools to ensure that the student can communicate together. And one last thing about doing this, there is one constraint about the synchronous activities, which is time difference. That, as you may know, that majority of the student is in Australia and China, and there are about 3 hours difference. So it's very hard to make a synchronous activities and ensure that the student can attend. So my
approach. We'll have to finish there, Patron, and move on to Rebecca.
Yeah. Okay.
So. Haven't quite finished the presentation, but people can have a look at the link that's on the table.
Yeah, actually it's almost done. Yeah, so it's all for my presentation. So thank you very much. Yeah.
Okay, great.
Yeah.
Awesome. Okay, gonna have to move on to Rebecca. Gonna have to keep them tight because we're gonna run over horrendously if we don't. Okay, Rebecca.
Okay, good morning, everyone. I'm just going to hide my. Okay, so my proposal is on a second year subject, which is ecology. So the ecology subject is the core second year subject in the Bachelor's of Science. Is taken by about 200 students a year from a number of different majors. This might include kind of the ecology major, the zoology, marine ecology, and it's taught cross schools, so it's across biosciences and geography. And so in doing this subject, the students, it used to be the first kind of subject that students took on ecology. And so they would learn kind of what is ecology, what are ecological systems, how do they change over time and space, what are some of the core ecological theories, concepts. They'd also learn how to collect and record ecological data and do basic analysis and write a report of that data as well. And so, and they would learn it on different scales. So it would start at the scale of an organism and go right up to communities. And so they should be able to explain this kind of hierarchical structure that ranges from kind of small to large scale concepts. And so the current course structure is this. So they have 2 hours of face-to-face lectures a week. Again, so like I said, these range from kind of the scope of ecology right up to ecosystems and applications, so throughout the semester. These are very directed, synchronous. Of course, they're also captured on lecture capture though, so the students can go back. So there is some aspect of asynchronous learning there. These are then supplemented by 3 hours of practicals each week, and the practicals are where they learn some of the ecological techniques for collecting data, and they have a practical manual that they have to fill in throughout the practical manual throughout the semester. And so this prac manual forms part of the assessment, so 25%, which is a quiz, and then 2 separate markings where they actually hand in their practice book and you get marks. They also have 1 day where they go out on an excursion to the intertidal in Williamstown, and they conduct a group research project, and then they have to write this up into an excursion report. And then they have a 2-hour theory exam within the exam period at the end of this as well. And so currently, I guess, this really falls on the kind of pedagogy, andragogy scale of the PAH spectrum. There's not a lot of room for kind of self-determined learning within this current structure. So the current ecology of resources that are used, these are very kind of focused around the Canvas or learning management system. They have announcements. Most of the, if not all the teaching is done face-to-face. They have lots of practicals. Their feedback is via the lab manuals, the quiz, and then just the speed grader for their reports. So In terms of, we're now revising this, doing a curriculum revamp of ecology. There are a few reasons for this. So first reason is that it's a very old subject, around 20 years old, and it's had a number of different changes over the years, which means that it kind of lacks a bit of coherence and is not built for the scale it currently operates at. And so it's obviously increased in students over time, and is logistically quite challenging. So for example, to have 200 students on a rocky shore over a day, or over 2 days, it usually is quite hard. Also, first year is being restructured. So first year will now contain some ecology subjects, which means that the second year ecology subject will no longer be their kind of first unit of ecology. And so that means that we need to, some of our content is moving to first year, and so we need to change our curriculum in second year. In terms of the SES scores, the practicals and field excursion were well liked, but feedback scored low. So the students weren't that keen on the lab manual assessment. They didn't feel like they received enough feedback from marking 1 to 2, so they didn't feel that they could learn throughout the semester. And a lot of them, it was the first time they've written a scientific report and done analysis. They didn't feel like they had enough support or knew what they were doing for that. They also found some of the lecture content unengaging. This, I think, in particular, was the first part of it, where we were just kind of explaining more about ecology, but others too complex. There's some of the more complex concepts. They found that they would benefit if they could have additional tutorials or something to help them understand. We do have Flex AP funding for this, to revamp this curriculum of $35,000. So in terms of the learning theories, when thinking about this assignment, was keen to create a course that is closer to the Hutagogy end of the PAH spectrum. And I aim to kind of apply a constructivism or social constructivism, I guess, theory to this, where the students would be more in charge of constructing knowledge along the course of the unit. And also to increase the depth of student understanding into the application of theory. And I thought that this would be well solved doing some of the kind of problem-based learning, because we actually apply kind of equations and theories, and they could actually apply this to a problem, and to make this problem authentic, which would help them apply it into real life scenarios. And so this is what we've ended up with, the 2021 course structure. So the lectures will be moved to online 15-minute videos. My chat. A little bit of time. So the lectures will be moved to online 15-minute videos. So one 15-minute video per lecture. So that's 24 in total. And these will explain the basic concepts. And so that means that we've actually still got, at the moment, 2 hours of face-to-face time. We haven't got rid of any of that. And so that kind of there was then questions about what might we do with those. Then there's going to be weekly formative assessment, so quizzes alongside these 15-minute videos that the students can test themselves with. And then there will be actually assessed quizzes, which will be worth 15%, which is every fortnight. And these quizzes will be based on problems, so they'll be kind of not regurgitating information. And then in terms of the practicals, so the first few weeks will be spent learning skills, how to collect data. And then they will have a much greater amount of time in the semester to do a group project. And this will allow for an iterative process of methods, reviews, and collections of data. And to aid with the understanding of the report, there'll be kind of a peer review of those methods early on, and then the final report will be due at the end. And so then the hope is that this will, I'm hoping to be able to design some activities that can then be a bit more student directed. And so I guess just go through these quickly now. So as I said, we have kind of quizzes, which will be kind of problem-based quizzes. But the face-to-face sessions could be used for a flipped classroom approach. And so there's a couple of different activities that I thought might take part in these. So it could be group problem-based activities, and every group could have something different and feedback to the class. So to kind of support peer learning. Also similar to what we did here, maybe some short group presentations where the students actually present on some application of the theory that's relevant to that lecture, and this could be something that the students chose to present on. And so this incorporates learnings from the kind of theories that I've described. In terms of the practicals, so the students will be able to choose their group project, and this it gives them time to think about how they're actually learning throughout the kind of weeks that they're doing this project for. And so in terms of getting peer feedback on their methods, they could do an Adobe Spark presentation just like this and get peer feedback via Google Forms as we're doing now. So in terms of ecology.
Okay, we'll have to stop there, Rebecca, unfortunately.
Yeah, no worries.
So over to Patrick, and while Patrick is setting up, I just had a post in the chat. If people give their feedback either in the Google form, because there's a comment thing at the end there, we're not going to have time for questions, unfortunately, today, or using your blog posts and as part of your post 4, that would be great. Awesome. Sorry, having to cut you off. Over to Patrick.
No, that's fine. I'll write about it in my blog.
Yeah, sounds good.
Hello, everyone. Good morning. I hope you can see my screen.
Yes.
I'm going to present to you on an online unit that I'm thinking of proposing in my faculty of architecture, building and planning. And this online unit is global cities. So as a bit of an overview to this subject, we increasingly live in a globalized world. So understanding cities or understanding your local area city is no more of an importance than its relationship with other cities globally. So this unit will transcend the local city region to a global or international level. So instead of looking at how cities like Melbourne are managed, we are now going to look beyond that and compare it with what is happening in other geographical locations in order to examine the central issues and processes that are affecting their planning system. So this unit is designed to provide an understanding of the current social, economic, environmental, and cultural concerns across cities and their relation to urban planning processes and outcomes. So these 5 key themes will underline the implementation of this unit: the economic, social, environmental, and cultural. So the learning objective for this unit, at the end of this, we expect, or students are expected to communicate their informed opinions on current planning issues and principles locally and globally. And also they should be in a position to analyze contemporary planning debates and the various value propositions. And they should also be able to determine solutions to identified urban problems and as well develop communication skills through independent research, essays, and presentations. So these are the learning outcomes for this proposed unit. And based on these learning outcomes, the unit adopts, the learning theory adopted for this unit is constructivism. And it is adopted because it focuses on how people learn. And by the overview that I've been given, students are going to explore more of how cities function and the relations between different cities and their planning outcomes. So the constructivism theory provides a better basis for students to observe and also to undertake a scientific study of the various cities that they may be looking at. Then it also allows students to engage with problems of our cities that we are facing then construct their own understanding in terms of preferring solutions or recommendations to improve or address the problems that they may identify. And of course, by experiencing diverse urban planning practices across different cities, the constructivism theory allows students to reflect on these experiences and how they can inform their solutions to the problems that they've identified. So these are the reasons underpinning the use of constructivism in this online unit. So based on the overview or the basis for this online unit, as well as the theory underlying it, which is constructivism, the learning design framework that is adopted is problem-based learning. And this problem-based learning is adopted for this unit because it is consistent with the constructivism theory, because it promotes active learning. It allows students to learn by doing. And it's also consistent with the learning outcomes for this unit, because students are going to study different problems in different cities and suggest or propose solutions to the problem that they've identified. It also encourages learning in groups and also individually. So the problem-based learning design framework is adopted or is used as the basis for developing this online unit. So the question is, why is problem-based learning critical for this particular unit? As I've indicated in my overview introduction, this unit positions students to inquire about pressing urban management questions. So questions such as, why do governments plan for cities that we live in? What kind of issues does planning respond to? And what are the concepts, strategies, and even the tools and ethics of that are involved in planning activities and responses? Then why do planning decisions make some cities well off and others not? And in short, why does understanding of different cities across the globe affect or influence the different planning regimes that we have? So if we are going to provide answers to these questions in order to address our learning outcomes or achieve our learning outcomes, then the problem-based learning framework is an important framework, because it gives students the opportunity, student and the educator, the opportunity to engage with the real-life issues and try to provide solutions based on their level of engagement and their level of understanding with these issues. So this is how the unit, should it be approved, will be delivered. It is purely online unit, and it will run for a period of 12 weeks, and it will be delivered through 2 channels. The first will be lectures, and the second will be tutorials. So we'll have 1 hour weekly Zoom meetings, and these Zoom meetings will be recorded as well to cater for students who are time constrained in terms of their geographical locations. Then as a way to cater for their needs, or the student who will be missing the online lectures, there will be an ongoing discussion on discussion board using a Canvas platform. Then there will be one and a half hours weekly tutorial meetings, and this will be designed such that it will reflect the various locations of the students. So students in a particular time zones will have a tutor who will respond to them at that particular time zone. Then we have students at different time zones presenting or engaging with their tutors at different period of the day, because it's purely online unit. So going forward, there will be 3 major learning activities for this unit, and all these learning activities are tied to the assessment of this unit, as well as the learning outcomes. So the first learning activity will involve a group presentation, then the second will involve a field survey, and the third will be a design of a poster. I will take them one by one and provide a bit of explanation to each. So regarding the group presentation, this will be the first assessment task that students will engage in, and it will be an Adobe Spark group presentation that will be delivered in class. And with this, students will be put into various groups, and they will be asked to, out of the 12 weeks topics that we'll be treating every week, they will be asked to select one topic each, then discuss as a group, research on it, and make a presentation on that in class using Adobe Spark. But for student engagement, prior to the presentation, the groups will be asked to upload their presentation onto a Flipboard platform so that students can comment, have a look at it, and also prepare their notes or questions prior to the class presentation to ensure that there's active engagement during class presentations. So the purpose of the group presentation, which is also the first assignment, which will be in group form, is to make sure that it achieves our learning objective or learning outcome of communicating informed opinions on contemporary planning issues and principles, both within and outside the cities that these students may find themselves. Then second, to develop their communication skills, since it will be in the form of a group presentation, and their communication skills in class, and also the report that they will prepare. So that will be the first assessment task. Then the second assessment task, which will occur somewhere around weeks 6 and 7, will involve a first survey. And this second assessment task, the first survey, it is because it's an online unit, I don't expect the student to go to the field and conduct a survey like a face-to-face survey, but it will be an online data collection using SurveyMonkeys. So within this context, students will be required to select 2 global cities, so one that they live in or familiar with, and one that contrasts.
I have to finish the Patrick.
Okay, one that contrasts with their current, the one that they've selected. So if they select a city like Melbourne, they should select another one in a developing region, or another one that is really different from Melbourne. And with these cities, in terms of demographic.
Okay, sorry, Patrick, we have to finish and move on to Chelsea.
So should I finish up?
No, we'll need to stop there.
Thank you.
So over to Chelsea.
Okay, thank you.
So you might hear a bit of a horn at 10 minutes because I've put a little bit of a sound on my timer.
No worries at all. Okay, everyone. So I'm talking to you about a subject called working with groups, and this is my online proposal. I'm fortunate to have the opportunity to be trialing this this current semester, so it's a little bit, you know, edit as we go. So I'm going to share with you some activities I've already had the chance to trial run as well today. So the student profile within this program is their psychology students at the master's level, so their final 2 years of training. So at the end of our course, the students can apply for their full registration as psychologists. So they come in as provisional psychs and they leave as fully registered practitioners. We have a smaller intake, so approximately 24 students per year intake, so I've got 24 in my class at the moment. And we have a combination of local, interstate and international students. Now what we've been looking at with moving online is a way to perhaps be able to deliver a lot of our course online, because it is very Melbourne centric, and international students and interstate students are moving to Melbourne to do the course. So if we can build a sustainable online and rigorous online program, then that's going to broaden our student base across Australia. So I'm really excited about that. So that's why I've chosen to look at this subject, and keen to get feedback from others too on what you think, how we're going with it. So just to start with, I just wanted to start with a look at design-based research. And so what I'm presenting to you today is really those first two parts of that process, which is really the analysis. So what does this subject hope to achieve? So I'm going to talk to you about the graduate attributes here and what am I trying to share with the students through this online proposal. And then the actual design of the subject. So what are the activities and how are the learners in the subject going to be engaging with each of those activities? So here are our key learning objectives, and it's hoped that by the end of the subject that the students will be able to meet all of these. Now they're mapped also against the assessment tasks and the learning activities in class as well, and also there's a feedback mechanism to that too, which I'll discuss a little bit further on. One thing I just wanted to point out here was that this subject is aligned with the Australian Qualifications Framework, AQF Level 9, and also with our professional standards for psychologists. So it is a professional level course. As I said, students will register as full psychologists at the end of it. But at this level of training, there are specific competencies that we need to make sure our postgraduate students have achieved. So I've just pulled out a number of those here that align with a group's framework. So we're not working with individual clients or thinking about individual clients in this subject. We're thinking about how to work with groups, whether that's family groups, peer groups, school groups, and the systems, looking through a systems approach. So this subject is constructively aligned when the learning outcomes, teaching activities and assessment are all working cohesively together. And I've added the feedback element to that as well, because we all know now through the learning that we've been doing how important it is that the students are getting critical feedback on their work, and we now have a range of digital mediums for doing that. One of those, of course, is the Google Forms that we're all giving feedback on to each other now. So that's something that I've looked to integrate as that fourth perspective with the constructive alignment. And I just wanted to put in the solo taxonomy here, because the subject being postgraduate is really looking at the top tier of that model, which is getting students to analyse, evaluate and create their own work. So we're moving further up to the upper end of that taxonomy. My ecology of resources is quite broad for this subject. It is largely a synchronous subject with some asynchronous elements, but similar to what other people have had, we've got our common interactive platforms and mediums there for students to be connecting with each other. One of the feedback mechanisms, feedback fruits, is something that I'm looking to explore and do some PD myself to get more up to speed on that. So I'm keen if anyone else has used feedback fruits, perhaps you can give me some tips on that. So this is just an outline of the first 6 sessions. I've chosen to focus on the first 6 in making them online. And you can see along the side there in terms of the mode of delivery, I've broken it down as to whether it's synchronous or asynchronous, and the digital tools that we'll be using to interact with the students. So you can see that there's a lot of different activities there, from using Kultura and different Google Sheets and forms, breakout rooms to get the students interacting. So largely the subject is influenced by 2 different learning theories. The first of those is the Constructivist Theory. And within that theory, the type of activities that are being utilised is that of the flipped classroom and the problem-based learning. So within the flipped classroom, students are really getting to be more active in that process and socially create their own learning. By doing, work collaboratively outside of class and then bringing that in together into a synchronous environment so that they can share what they're doing. And those tasks are very much framed around problem-based learning opportunities. I do also feel, though, that the PAS theory is informing what we're doing. Probably most of all andragogy, it is adult learning, and given the accreditation requirements, there's not, it can't allow too much self-determined learning because of the accreditation requirements and making sure that students have certain competencies, but how they arrive at that place, there can be some flexibility in students choosing to expand their knowledge in certain areas and bringing their own interest into their assessment and the collaboration they have with other students. I just wanted to share with you 2 activities that I'm trialling in this class. This first one here is called the Jigsaw Method, which I've stolen here from John Hattie, in which students are looking at a different aspect of family and will go and research that different area. So it might be the impact of divorce, or it might be, you know, blended families. Students will independently go and research that aspect in small groups and then come back together during our synchronous time to share their learning. So that's why it's called the Jigsaw Method, is you've got, say, 5 different students who've explored a different area. They come together and they share each other what they've learnt. So they're teaching each other. The other activity, which I actually gave a try last week, so this was inspired by SeekBeak. So I actually created my own escape room for the students to interact. And as you can see here, this is a little view inside my escape room where different activities popped up and the students had to work in teams and groups to solve these problems together. I have to say it did work quite well. The students really enjoyed that sort of element of fun whilst also working together. So you can, at your leisure, have a little look through the escape room if you like. So I know my time's coming to an end. That was really the last activity I wanted to share. I've just popped the DBR image here again, because hopefully in the next presentation I'll look at the last 2 elements of that process. And I'll leave it there. Thank you.
Awesome. Just over 30 seconds to go. We thank you, Chelsea. Let's move on to Brooke and Katie. Thanks for keeping to time. That was awesome. Better reset my timer.
Okay. Everybody can see my screen?
It's working, cool.
Yep. Okay, so good morning, everybody. So Katie and I worked on this project together, or this assignment together. So it's developing a blended subject. So this subject is Introduction to Biomaterials. So it's different to the subject that I'm teaching this year. In our department, we've currently in the middle of a curriculum review. So it's going to be moving from a 9,000 subject to a 3,000 subject. So it's going to be a 3rd year undergraduate subject. However, based on the master's degree, some master students will take it because this will be a core subject. So it's a subject that's part of the Bachelor of Science, Bioengineering Systems, or Masters of Engineering, Biomedical Engineering. So students, if they do it as an undergraduate subject, they're doing it in a science degree. So they'll have a chemistry, maths and physics background. And then if they've come in as a master's students, they will have pretty much the same background as well with engineering. So the students will have a they'll be computer literate, they'll be library literate, and so it's part of the engineering degree. So this subject, as I said, it's Introduction to Biomaterials. So the aim of this subject, or it's been designed to enable students to apply fundamental principles of material sciences to biomedical applications. And it's going to introduce different materials such as polymers, metals, ceramics, and composites to students, and also look at how the behavior of these materials when you put it in a biological environment. And while we're talking about synthetic materials like polymers, ceramics and metals, will also go into different properties of biological materials that are found in the body like bone, muscle, skin and vascular. So here are their intended learning outcomes of the subject. So describe the material science and engineering requirements related to biomaterials, explain the complexity in the application of materials in biology, describe practical aspects of biomaterials, critically reflect on and apply basic regulatory and ethical concepts of biomaterials. And the last one is construct a protocol to evaluate material properties. So now I'll pass it over to Katie for a sec.
So we've designed this subject using the conversational framework that embraces the notion that teaching is a dialogue, and it employs multiple learning theories. Brooke, my screen hasn't updated. Has your screen rolled down to the, oh, great, thanks. So it embraces multiple learning theories, including instructionism, which is the teacher-focused non-interactive theory, and social learning to emphasize the social aspect of learning where students observe and imitate others. Constructionism, that is student-focused and interactive, and collaborative learning where there's peer-to-peer learning that promotes deep thinking and communication. And it does this by, it's using the conversational ABC based on the pedagogical theory of Diana Laurillard. And so it uses the learning theories by, so in this picture, I'm not sure if you can see my arrow because I'm not the host, but so students go through acquiring, where they learn through listening, reading or watching, and that's the instructional learning. They go through inquiring by learning through investigation, which requires them to explore and compare and critique resources. Then they go through producing, where the learner consolidates what they've learned by articulating and applying it in practice. They have a discussing component, which requires the students to articulate their ideas and question and respond to other student ideas. Collaborating enables discussing and practice and production that builds on that inquiry and acquisition. And then finally practicing, where the student adapts their actions and uses the feedback. So in terms of this diagram, it has the learner at the center, and the learner interacts with the teacher and the peers. And in the upper level, the learner communicates with both the teacher and the peers. In the lower level, they share their practice through actions and feedback in a learning environment, where each interaction, which is an arrow, is an opportunity to develop. So concepts, the student creates concepts in their mind, and that generates an action and then feedback from the learning environment. And that's an iterative process that allows them to get increasingly deep learning throughout the course. Okay, back to Brooke.
So how will we be using these different learning types in the subject? So acquiring, so where will the students get, how will the students learn in this subject? So they'll have lecture content, information from textbooks and journal articles, and watching in-class demonstrations. Collaboration, so how will the students learn from each other? There'll be group projects, discussing other inputs and building on joint output. Discussion, so how will the students articulate their ideas? So in terms of, there'll be workshops and tutorials, discussion group seminars and in-class discussions. And I'm going to go through the exact details of how it will be done in the class in a sec. And then learning through practice. Within this subject, there'll be workshops and laboratories as well. And then producing artifacts. So what will they be producing to demonstrate what they have learnt? So there'll be presentations, a lab report, and they have to produce a model of an implant. So how is the subject designed? So there will be lectures. Currently there are 3 one-hour lectures. So next year, when I've redesigned the subject, it will go to 2 one-hour lectures. It will be face-to-face synchronous lectures. But as a lot of the subject, or as all subjects are now, there still is lecture capture. So if students can't view the lecture synchronously, they can view it after time. In my lectures, I will include things like Poll EV to initiate discussion, and also to test short bits of knowledge that have been learnt in the subject. Because I am taking away some of, or the 1 hour of lecture, it's being replaced per week with some videos, and then also content of this subject is based, or is from a textbook and journal articles as well. There will be workshops. So one of the activities in the workshop, time, there's going to be 2 labs in this subject. But before the laboratories, what the students will have to do is design their own practical in place. So they will be given an outline of what they have to do, but they actually have to come up with the lab prac. So by doing this, they're learning they're using a whole different range of the learning practices. They will also have a group project, so this will be done in teams, and they have to, it will be an open-ended design project where I will tell them, or I'll give them 4 different applications, and then the students can choose which application that they want to do. So this goes back to the social constructivism, and then giving the students the chance to do a project on what interests them rather than telling them exactly what to do. And then there's going to be exams and quizzes as well. So I'll hand it back to Katie, and she'll talk about the EOR.
So the ecology of resources used in this subject, there's going to be a discussion board, and so a component of each lab is evidence of active participation in the discussion board. So each week a tutor will pose 2 conceptual problems, and the students have to discuss their thoughts and answers to these problems. There will be SurveyMonkey to enable peer evaluation of group presentations. Poll EV allows for a formative assessment after instructional learning. The Canvas quiz throughout the semester for formative assessment, and they'll be using Google Docs to write lab reports. Adobe Spark to build their group presentation, and which will then be published on YouTube.
And here's the references, and that's all from us. Thank you.
Awesome, thank you. Good teamwork, and with 1 minute to spare, so I think we'll hand over to Lyle. So we are a couple of minutes behind. Thank you very much.
No worries.
I'll just reset my timer here. Yes,
Can you see it, folks?
Yes, we can now see your screen. Awesome.
Okay. No worries. Let me just move you all over so I can see what I'm doing. Hi everyone, I'm going to talk to you about Bayesian statistical methods, a subject that I've been teaching for a while, but is in need of redevelopment. I'm not going to go through the outline, but I'm going to take you through a bit of background and then talk through the other components of design and learning. The subject sits within a master's degree that's delivered by the Biostatistics Collaboration of Australia. This is a nationwide collaboration of 6 universities that provides postgraduate training in biostatistics. There's a link there if you wish to have a look yourself. The students who are enrolled will enroll in one of these 6 participating universities. The Master of Statistics is entirely online. It's available at the moment only to Australian students because they've got to satisfy the on-campus requirement if they're going to be international, but I anticipate that will change after the experience of this year. There are 2 streams. There's a health stream and a mathematics stream, people coming in from those undergraduate backgrounds, and they're expected to learn about the other stream by taking corresponding subjects in mathematics background or epidemiology and public health background. The people who enroll are typically mature age. They're either career changes or what I call DIY. They're people who work in health medical research, got sick of not being able to find a statistician to help them out, so they decided to become one themselves. It's essentially a part-time course. It's relatively hard to articulate the subjects for a full-time enrolment, and many students take 2 or even 1 subject per semester and take many years to complete. So we describe it as being very part-time. Completing the Master of Biostatistics gives you automatic join the Statistical Society as a graduate statistician. So it's one of only a couple of courses that puts you on the pathway to accreditation with the Statistical Society of Australia as a consultant statistician. Bayesian statistics is a theory for statistical inference based on full probability modelling. It's much more general and subsumes the dominant paradigm of frequentist statistics. That's the one that gives us p-values, a tool for inference you might have heard of. Until recently, Bayesian statistics as a discipline was boutique. It was heavy on theory, a lot of computational demands to actually do the calculations. So it was seen as something that could tackle only specific problems, and typically taught using toy examples. That all changed in 1995 with the development and release of the BUGS software, Bayesian Inference using Gibbs sampling. This was developed by the Biostatistics unit at Cambridge in the UK. And the release of BUGS really revolutionised the use of Bayesian statistics. It did for full probability modelling, or what Bill Gates and Steve Jobs did for microprocessors and microcomputing in the home. BUGS was superseded by a platform called STAN about 5 years ago. STAN is a much more general platform for statistical modelling and high performance statistical computation. It goes well beyond the bounds of fitting the sort of statistical models that we would typically be doing with our students in biostatistics. STAN requires a lot of scaffolding and a lot of infrastructure. You need development tools. You really need to understand programming to an extent that wasn't necessary with BUGS. And it produces compiled executable routines using C++ compiler. So you need development tools and all sorts of things installed. It's a pretty big deal, but we felt that after 10 or 15, or for some of us 20 years using BUGS, which was not really working on modern Windows platforms, it was time to make the change. So the last time around the subject, off we went. Here are the student experience surveys from semester 2 a couple of years ago. There are 6 subjects that were on, and you can see that Bayesian methods fared pretty poorly. We just saw red all the way down the line because students had a really terrible experience trying to set up STAN and trying to do the exercises in it. So my primary problem is to work out how to deal with that computing aspect. The learning objectives, we fall into 2 groups. There's the first set where we look at the logic and philosophy of the theory of Bayesian inference, and the second set, which is the one that's of concern with the STAN software, is Bayesian data analysis. We teach students at least something about the most basic hierarchical model and the relevant computational techniques so that they can tackle what we call in health and medical research realistically complex problems rather than the toy examples of yesteryear. This diagram demonstrates the existing resources that we have in this subject, and in fact the other subjects that form part of the Master of Biostatistics suite in the BCA. So for each of 6 fortnightly modules, students get module notes, which is effectively an in-house textbook, a couple of 100 pages worth of stuff that the instructors put together. They get readings from relevant research papers. In the theory part, we do exercises and practical questions. In the computing part, there's analyses and programming code that they try to work with. The only opportunity for feedback was through the online discussions board. We have question and answer with the other students and the instructor. And then there's an assessment task, and then we loop back to the top. So what's really important here is that until recently, it was just the module notes and just the reading. No lectures, there's no tutorials, no videos, no nothing. And we really had to sort of pull ourselves up by our bootstraps to try and try to get into the 21st century. Now, how are we going to do that? I think the first half is more straightforward than the second. The design framework that I propose would be a flipped classroom. The material's already distributed in advance. So these people are adult learners. They're highly motivated. They're able to be on discussions and email at regular intervals. So I think something where if we could find a way of coming back together with them and trying to consolidate the material after they've sort of taken time to assimilate themselves, it would be great. The learning theory, I think behaviourism combined with cognitive load, they need to be able to recognise the maths, concept theory and so on. but they need a lot of revision, different backgrounds. I'm thinking our ecology of resources might start with the recent textbooks that have got stuff on STAN, graded examples, online resources, but these will need to be heavily curated. And the students find it really intimidating when you figure from one textbook, so well, I don't know which bit of that to look at. Similarly with papers, and you've got to throw out the maths and look for papers in medicine, and a couple of examples here, and even the law. Here's an example about expert witnesses using Bayesian methods, and of course, most recently infectious diseases. So I think we've got to make the switch, or I believe we say pivot these days, from mathematical statistics papers to applied papers. I think video is really important. Here's something I tried to put together myself, demonstrating iterative simulation. I'll take the time to go through it now. The second half, I think we would need to use the Laurellade's conversational framework, the bidirectional dialogue, to an understanding through learner and teacher. Autonomy plus guidance, this is great for the students. Some of them are very independent, others want more. And the forms and affordances is also a great idea through narrative, where relatively little changes with student intervention through to producing and creating your own stuff. And social constructivism, I think, is really important for program. Part of Naman was saying, like, a blog post, that students learn software development through talking about it and getting together. I think that's really important. They really struggle to do it themselves. So sorry about the fuzzy stuff, but here's my pitch for something that I think might work if we have a gradation of tasks and students come in at a level from manual hand calculation to simple software right through to using package routines, and then writing scripts, finally through to functions, compiling code, and making applications. And these are the software that we would use to do that. So that's another ecology of resources there. I think this sort of thing.
Move on to Daniel. Sure. Sorry.
No worries. Thanks a lot. That virtually. Okay. Thank you.
But definitely everyone needs to go look at each other's presentations and catch up on the bits that we don't quite get through. Over to Daniel.
All right, let me share my screen.
It's obviously quite hard to squeeze into 10 minutes, but we'll do what we can. Yep, that's working. Thanks, Daniel.
Okay. Slowly loading on my screen.
That's the vagaries of the internet, isn't it?
Yeah. I have 3 online learners at home, so. All right, so this is the draft course we designed for Info 9001, which is a course that I inherited last year, taught for the first time, and it's called Health Informatics Tools and Methods, and I'm teaching it this year for the first time fully online. So some basic information about the course. It's a core course in the Masters of Information Systems and its health stream, and a graduate certificate in health informatics. This is, it fulfills the role of the research methods course requirement for the future research capstone. Used to be face-to-face, and we had diverse educational backgrounds. About 75% of students were IT and computer science, and a few clinicians. Many of them were full-time workers, and it's taught on Mondays from 5:30 to 8:30 p.m. These are the learning objectives from the handbook, but the gist is that they need to learn about health informatics tools as well as health informatics research methods. So it wasn't so easy to combine those two things together. The graduate profile, we are targeting health informatics practitioners to be able to read, critically appraise, and apply evidence from health informatics research. And the health informatics researchers at the master's level, they need to be able to identify a research problem, explain its significance, elaborate a research proposed question, and choose research methods and elaborate a research proposal. The main challenges we faced last year was, I would say, big lack of understanding of healthcare system and healthcare problems, especially in the IT crowd, limited exposure to health information systems or health data, little or no experience with biomedical literature, and of course this year's challenge of going fully online. And the enrollment increased at about 80% this year, and this is the the students' educational background this year. We have way more clinicians than we used to have last year. And the proportion, the numbers of IT students is about the same, but the proportion is smaller. So for the design framework, I started with assessing of the problems that I just mentioned, mapping to solutions, and I like this idea of design patterns, building prototypes, and continuous evaluation. So for the learning theories and strategies to inform the course we design, I base my design in social constructivism, understanding that we have a diverse group of learners. So I wanted to foster, the social construction of knowledge and peer learning opportunities, which allowed students with clinical and IT backgrounds to learn from each other. So most of the work that is going to be happening this semester is group-based learning and activities. And I created the groups myself. They were not randomly created. I generated a survey to understand what were their backgrounds and learning objectives. So based on that, the groups were created. Authentic learning, experience with real biomedical literature, real research proposals, and realistic clinical data. And the flipped classroom for the core content will be delivered through asynchronous activities to allow synchronous discussion of complex concepts. So I, came up with my design pattern, and a design pattern is a semi-structured description of an expert method for solving a recurrent problem. The recurrent problems were these three: complex concepts will be flipped, applied activities will be implemented using realistic or authentic scenarios, and applied activities will be implemented using group work to enhance collective building of knowledge and peer learning. So a bit of the learning activities. The course has different layers. Here in pink, you see the health informatic tools are around research, knowledge translation, health data science, and simulation in healthcare. Then the addition on top of that, the research method layer, where we talk about research questions, the PICO framework, and so on. Then we have the group work layer, where they need to work on signing and creating and signing a group contract that's going to guide how they're going to work during the semester, identifying a research problem, designing their clinical decision support systems, using publicly available clinical data sets to generate digital phenotypes, and simulating the propagation of infectious diseases, which is very timely and a teachable moment these days. They also need to work on individual assignments, where they do create research questions and literature searches, identifying supporting evidence for digital health interventions, visualization of Medicare claims, and process mining using the Cynthia dataset, which is a synthetic clinical dataset. And also during the whole semester, they need to work in a group assignment, creating an NHMRC style grant proposal. These two things had some slightly different things than the authentic versions of them. So for the group assignment, at the end, instead of saying, what resources they do have to complete this research proposal, they need to reflect on what knowledge and resources they need to achieve, or collaborations that they need to establish to be able to achieve or complete this research proposal. And for the individual assignments, in each one of the individual assignments, I added an additional question asking about their individual learning needs, which will be the iterative feedback for the course along the semester. And for the ecology of resources, there's some tools for research collaboration like Google Drive, Overleaf, and GitHub. We're going to be using some public data sets, which is Mimic3 data set, Medicare claims, and Cynthia, which is a synthetic clinical data set. We're going to use some literature databases and tools like PubMed, Mendeley, and Epistemonicos. Some data analysis tools like JupyterLab, Tableau, and Apromore, and networking tools. We haven't tried this yet, but we're going to start using our own hashtag. As I mentioned, the initial evaluation was done with a survey to document students' learning objectives. I would say that mostly what they wanted was a hands-on experience. That was the overwhelming message that we received. And each individual assessment contains questions about learning needs. That's a word cloud of what they actually described in the open-ended question for the survey. And those are my references. So thank you.
Awesome. Thank you, Daniel. So next up we have Helen. I'll just give Helen co-host. So over to you, Helen.
Thank you. Thanks, Tom. Okay, can everyone hear me okay?
Mm-hmm.
Is that good? Okay, good. Yep. Thank you. Okay, let's move here. Okay, so I am talking about the subject Global Foundations of Architecture. This is a subject that I've worked as a senior tutor in, so I'm not speaking as a course coordinator here. And the online subject that I'm proposing is a little bit different from the current iteration of the subject. So just some background. It's a first-year survey course in the Bachelor of Design. So it's a foundational subject. It's the stepping stones, if you like, for the second and third year undergraduate architectural history subjects. It's quite large with 550 students. This semester, 75% are local, 75% are local and 25% international. Normally that's about half and half. And of the international student cohort, the vast majority are from mainland China. It's also quite diverse in the sense that Bachelor of Design students, architecture majors do it as a core subject, but we also get quite a lot of planning and construction majors and quite a few Brett students from arts, engineering and music in particular. So in terms of challenges, I guess the challenges and the strengths are sort of the same, very diverse student cohort. But what I love about this subject is that it's actually very easy to create quite a dynamic community of learners, even at first year, because that kind of mix of different nationalities, culture, religion, geographical locations is really great for talking about architecture and urban environments. So it is definitely a strength of the course and feeds into the pedagogical approach that I recommend the course takes. So in terms of the intended learning outcomes, they're very much based on the foundational academic skills for the discipline of architecture, architectural history. They also include research skills, critical thinking skills, of course, and communication skills. So oral, written, and graphic communication skills. And in terms of generic skills, again, fairly standard ones for the Bachelor of Design faculty, but I've emphasised here work collaboratively and productively in teams. I think this is a very important generic skill to emphasise, and both the intended learning outcomes and the generic skills have been mapped to the Bachelor of Design graduate attributes and generic skills, and also the University of Melbourne graduate attributes. And I think it's really crucial starting with these ILOs. Biggs in particular emphasises that well-framed ILOs are, the chief elements of good teaching. but encourage conceptual change in students. So they need to be clear, and also students need to be motivated to achieve them. Okay. So for this online subject, the flipped classroom approach has been adopted, and there are some strong reasons for doing this. I think the most important one is that it takes those lower levels of learning on Bloom's taxonomy outside the classroom. There is quite a lot of just recognising buildings, recognising architectural styles, recognising city plans in this subject. So students can learn those through online lectures before face-to-face contact. It also means the subject coordinator doesn't have to be the disciplinary expert all the time. A broader community of experts can be drawn upon to produce these online lectures, which is very important, I think, and Michael Henderson emphasises this. For example, we teach Indigenous architecture. We have a fantastic Indigenous architect in the faculty, Jeffer Greenaway. It'd be great to have him teach this component. The face-to-face teaching focuses on building skills in students, academic and architectural skills, and using active learning exercises. And with a flipped classroom, of course, there's flexibility. Students can access lectures when they want them. It reflects cognitive load theory. Students have control over their pre-class learning. And it also, of course, highlights the role of social interaction. So we want to be, even at first year, we want to be starting our students on self-directed learning, and this aids a transition later on to a pedagogical learning. So this is the sort of rationale, I guess, for this approach. Okay. So in terms of teaching and learning activities, the subject's a 12.5 subject. There are 3 hours. So one of these is the asynchronous lectures. The lecture program is divided into 4 thematic modules. We don't tend to be comprehensive, from the ancient Assyrians to the Baroque. It's a very broad first year survey course. So the idea is actually through this method to look at building types in depth and avoid superficial learning. The new introduction in this online course is a synchronous workshop, which is led by the course coordinator, the lecturer. So this is trying to take advantage of the face-to-face contact, if you like, that the students have with the subject expert. So in these workshops, they focus on studying case studies, analysis, discipline-specific skills like reading plans, understanding style, visually analysing buildings, understanding construction techniques and how they apply to use of particular materials historically. So this is requiring functioning knowledge, and the lecturer sort of models scholarly methods. So it's a very productive way, I think, of using the expert in the classroom. And then the last hour is small group tutor-led facilitated learning. So this alternates, it's varied between tutorial reading analysis and debate, academic skills training, virtual site visits, which is a key component I'm working on at the moment, and group assignment work, which involves peer feedback as well. So there's a strong emphasis on active learning exercises, which of course all occur on Zoom, and I'll go into some of those technologies that enable this shortly. So the assessment tasks are designed to be nested, and they're designed to be formative as much as possible. The radical change is deleting the exam because it encourages sort of superficial learning, and having too much content, having an overcrowded curriculum sort of defeats the purpose of trying to engage in deep learning. So encourage students to develop their critical thinking skills and develop their academic skills. So in terms of the formative design of the course, students lead class discussion in a reading exercise. They write a thesis statement for their essay with an annotated bibliography, which is a formative task for the essay. And I guess the main interesting activity is their group exercise, where they do a heritage assessment of a building as a team and then present this as either a poster or a video, and then present their findings in an oral presentation to class. And a final research essay. Okay. So, sorry. Yeah, sorry. So in terms of the learning philosophy, the pedagogical philosophy underpinning this is social constructivism. So obviously based on the theories of Dewey, Piaget and Vygotsky, which understands that knowledge is constructed within social contexts, that learning is collaborative, that students are motivated both by intrinsic academic curiosity and interest, but also by the extrinsic motivation of working with their peers, having that engagement and having that recognition. So the aim of this course is that the teacher functions much more as a guide and a facilitator to accelerate learning, and understanding that in a group, more can be achieved than working as an individual. So encouraging students to work collaboratively encourages multiple viewpoints, discussions, and problem-solving approaches. Okay, let's skip on. Okay. So this is just an example of how this would function. So there would be the pre-recorded lecture for one module. This is the module on early settlement and the city. And then when you came to the workshop, there'd be a combination of an analysis of examples, of case studies.
We'll have to stop there, sorry, Helen.
Oh, okay, sorry, okay.
So our last presenter for this session is Chris. Over to Chris.
All right, so the subject that I'll be teaching online is data structures and algorithms. And the main way I'm approaching this is through a problem-based learning framework. So the goal of this subject is to give students all the tools they need to think about algorithms, think about problems like a computer scientist, and design appropriate algorithms to solve a problem. So there's very few facts that we actually need to communicate in this course. It's really all about learning skills and techniques. And so the goal is to equip students with a kind of mental toolkit that they can use in their future careers as computer scientists, or in fact in any field where they might be working with data or algorithms for designing and understanding how these things work. So the students are mostly second-year undergraduates. Many of them, but not all of them, are majoring in computer science or engineering. They will have had 1 or 2 semesters of programming before they come into our subject, but there's sort of a variety of programming backgrounds and they've learned different languages. And they're a very international cohort. So they come from a wide range of diverse backgrounds, and because we're teaching online, they're actually located in a bunch of different countries. So the intended learning outcomes of the subject are the students should be able to analyze algorithms in a theoretical sense, so understand the mathematical or logic tools that you use to understand algorithms. They need to be able to reason about the efficiency of an algorithm and whether it's actually fast enough to solve a real-world task. They need to be able to choose appropriate data structures and algorithms and actually be able to implement those themselves in code. So in building our online community of inquiry, we've made reference to the theories of Ling. So the educational experience arises from the combination of social presence, cognitive presence, and teaching presence, which are these sort of overlapping spheres. Teaching presence is how we set up the material for the students, cognitive presence being the students' actual engagement in the activities, and social presence being the social community of the subject. So taking a problem-based learning approach, I'm relying both on the constructionist view of learning. So learning is actively constructed through experimentation and activities, and also taking a social constructionist approach. So we think that learning is constructed through interaction with your peers as well. So in terms of the course material, the hub for this subject is the Canvas LMS. And every week we put up a collection of curated material with the idea that students don't need to go through every single piece of this material. They can kind of pick and choose the elements that are most important to them or most interesting to them. But these are the kind of foundational ideas that we think students are going to need to tackle the problems that we're going to present to them that week. So it's a combination of pre-recorded videos, some reading suggestions, some cool online demos or tools that they can play around with, and some quizzes. And the week's activities consist of an online Zoom discussion with the students, going over the week's material, which again is phrased around specific problems. So I either propose some theoretical problems that have sort of open-ended solutions, ask them to break out into groups, brainstorm some ideas, and then we come back and discuss. Or I might give them a piece of code and ask them to break out into groups, play with the code, analyze the code, tell me what they think of the code, maybe come up with some ways they could improve the code. So here's an example. And I guess if you don't know C, this is sort of hard to read, but this is a code that computes the Fibonacci numbers. If you give it an input, you can execute it. And it works okay, but it actually has some issues. So if you give it certain inputs, it just isn't going to work. And so the goal of this task was for students to discover that fact and also come up with some ideas about why that was happening in this particular piece of code. So in addition to the live discussions, we also run 2 hours of Zoom workshops, which again are based around a problem-based learning approach. So posing programming problems to the students, and in this case, actually asking them to design their own C code to solve those problems. And finally, there are 3 assessed programming assignments, where students are expected to use the tools that they've developed over the subject to solve a sort of open-ended algorithmic problem. So in addition to this, we are also really making an effort to build the online community for the subject, because when the subject was taught online, we really did rely on a social constructivist approach to learning, where students very often worked in groups and discussed with each other. So we're doing that through encouraging breakout discussions in the Zoom during both the lecture and the workshop. All of the workshop programming is done collaboratively. So we've set up online collaborative programming tools for 2 students or 3 students will work together on the same project. And we also encourage students to participate in the Piazza Forum, which is a discussion board similar to the one you have in Canvas, but it really promotes collaboration because everybody can freely edit everybody else's answers. So this is the ecology of resources for the subject. As I said, the subject hub is the Canvas LMS. We're encouraging students to develop their own code and post it themselves on GitHub. And for collaborating on code, we're using Jupyter Hub and Ed. And I think we're exploring some other tools as well, just to get a sense of what works there. Students can work on their own devices using their own IDEs. And we also have communication routes through Piazza and email. And I do in fact encourage the students first to post on Piazza rather than emailing me directly, just so we can make all the discussions as open and social as possible and get as much of the class involved as possible. So finally, I want to note some of the priorities we've had to balance in this subject. So we're having people do collaborative programming online on Jupyter Hub, which is great and it's a great learning environment, but it's not very realistic. It's not the authentic learning environment, or so the authentic coding environment that students will use when they go out into industry. So we've had some debates about whether we should make it more authentic, but there's a pretty steep learning curve to get people set up with their own IDEs in a more authentic way. And so we're going with the Jupyter Hub, which is a little less authentic, but more collaborative. And the other thing we've had to balance is trying to build this social community, but also respect student privacy. So Piazza, for example, is anonymous, and the anonymity makes it kind of difficult for students to build relationships with other students because all the posts are anonymous. But I think that's also important because it encourages students to participate. Yeah, so just to sum up, those are some of the references I used in this design.
Great, thank you, Chris. And 3 minutes to spare. Awesome. So we've got a break. Go and grab a coffee, cup of tea, whatever, you know, get your brain working. It's been pretty intense with the presentations. We'll have our next lot of presentations, which is not quite full, but we do have Brian right at the last slot. So we have to see if Brian might be able to do his slightly earlier, but we'll see how we go. So if we could, as many as possible, get back here online. I'm just trying to work backwards. I think it is 12:30 your time, yes. Just trying to have to translate my time back into yours. So we'll see you all again then. Thank you very much. Very good presentations. And don't forget to post your Google form feedback, and throughout the rest of the week as well, work on your post for and comments, which hopefully will be focused around this initial course design. Thank you all.
Thank you. See you guys later.
See ya.
Bye.